So we are looking at the structures of amino acids. We want to draw the 20 amino acids. The simplest way to draw them. So listen, everybody can draw it. Even people that are tired can draw it. Now, let's start with the simplest amino acid. The simplest amino acid is glycine. But now look up. All amino acids have this part. So if you are asked to draw amino acid, even if you don't know what to draw yet, this is the structure of all the 20 amino acids. Amino acid have 4 parts connected to a central chiral carbon. This, the amino group, the carboxylic acid group, hydrogen, and what? Arrow chain. It is this arrow chain that differentiates one amino acid from the other amino acid, right? So in the 20 amino acid, the only thing we are going to be changing is only this arrow. So if you are asked to draw any amino acid at all, this other part remains the same, right? This is only here that is changing. So glycine is the simplest amino acid. And if you don't know how to draw any other one, you must know how to draw glycine because it's the simplest one. Now, for glycine, this arrow group is what? Hydrogen. This is glycine. Please don't, I'll give you time to draw it. Just listen up. Let's draw them together first. This is glycine. So glycine have what as the arrow group? Hydrogen, right? Let's draw the next simple one, alanine. Now alanine, even if you don't know what to draw the part that remains constant, right? NH2 COOH. Then you've drawn the part that remains constant. Then this one, you now ask for God to give you the grace. Now, this other part, now the arrow group for glycine is H, right? The arrow group for alanine is CH3. Methyl group. This is alanine. Is it not simple? That is how all of them they are simple like this. Number 3 now. Let's look at valine. People at the back, can you see this? So I bring it up. Let me take it up. All right, number 3. Let's look at valine. I'll give you time to draw. Please, let's draw it together. Valine starts with what? Now look at this. Let's draw the part that remains constant. NH2 COOH, right? Now, one thing you should notice, all other amino acids, apart from glycine, is a derivative of alanine. We are just adding something to alanine, and that's all. And good thing now, all of you know the structure of alanine, right? So we'll just be adding something to alanine to get all other amino acids remaining. Do we get that? Now for valine is starting with what? Starting with V, right? Now the structure of valine, that arrow chain looks like V. That's the simplest way to remember the structure of valine. Now this is, if I have something like this, what is this? Alanine, right? To make it look like inverted V. This is V, right? Inverted V is like what? Like this, right? Is it not looking like inverted V? This is structure of valine. This is structure of valine. Looks like inverted V. Good. So that's valine. The next one is what? Isoleucine. Well, let's draw leucine first. Okay, isoleucine. Now, as usual, we'll draw our alanine first, right? Now, for alanine, NH2 okay, for some reasons, let me draw leucine first. The structures are almost the same thing, they're isomers. Now, this structure is the structure of what? Alanine, right? Yes. If I have something like this, What do I have? If you notice, it's just like I added one methylene group to valine, right? Is it not? It's just like I added one methylene group to valine to get what? Leucine. So the V shape is still there, is it not? So this is the structure of leucine. Then the next one is what? Isoleucine. As you can hear the name, isoleucine. It means leucine and isoleucine are what? They are what? They are isomers. Just hold on. Alright, so let's draw the structure of isoleucine. Now the structure of isoleucine. Please look at this. If you notice, there are two methyl groups attached here, right? If you take one methyl group and attach it on this position 1, that's isoleucine. From leucine, if you take one methyl group from here and attach it to position 1, that's isoleucine. So we'll be having the same structure. Now this methyl group is no longer here, but now here, right? Do we get? I'm just bending it so you see how I removed only this one. If not, you can put it straight. Do you understand? This structure we have here is isoleucine. Please write this 5 down. Draw this 5. Now, number 6. Number 6 in our structure. Let's draw the acidic amino acids. The acidic amino acids are what? Aspartic acid and what? Glutamic acid, right? These are the simplest to draw. So you are starting from the simpler ones. Aspartic acid and glutamic acid. Now let's start with aspartic acid. Now from the word aspartic acid, it means this amino acid is acidic, right? It's acidic. And acidic amino acids are monoamino dicarboxylic acid, right? They have one amino group and 2 carboxylic acid groups. Now if we have this, the general structure, is this in basic or acidic? As it is. Neutral, right? Because it's monoamino monocarboxylic, right? I told you other ones are derivative of what? Alanine, right? So if I have this as alanine, if I attach a carboxylic acid group to alanine, something like this, is this acidic or basic? Acidic, right? Because this base will cancel the effect of this acid, but we still have another acid here, right? This structure we have on the board, just adding carboxylic acid to alanine is aspartic acid. This structure here is aspartic acid. Number 7, let's look at glutamic acid. Glutamic acid is still acidic, right? Glutamic acid, just increase the chain a little. Just add a methylene group. So we'll be having this. CH2, another CH2, before we have COOH. So you see that glutamic acid is one methylene group longer than aspartic acid, right? Good. Now these are the acidic amino acids. But please, I'll give you time to draw. Just listen up. Number 8. Let's draw the amide amino acids. Because they are, if you know the structure of the acidic, you know the structure of the amide. That's a good thing. The amide amino acids are what and what? Asparagine and what? Glutamine, right? Asparagine is the amide counterpart of aspartic acid. Glutamine is the amide counterpart of what? Glutamic acid. So let's draw asparagine. Asparagine. Now to draw asparagine, you still draw your alanine, right? Now if it was aspartic acid you wanted to draw, we write COOH, right? This is same thing as COOH now. This stuff here is same thing as this. But we said asparagine is an amide amino acid, right? Amide is like this. Right? Amide, we have amino group linked to a carbonate carbon. This amide. We already have a carbonate carbon here, right? So to convert it to an amide, what do I do? And what do I put here? This asparagine. As you can see, there's an amide. This is an amide, right? This asparagine. I just remove OH from aspartic acid and put NH2. I get asparagine. So with this, all of us, we can draw glutamine, right? Right? We can all draw glutamine. And let's draw it together. To draw the structure of glutamine, what do? We just draw glutamic acid, right? Instead of OH, we put what? NH2, right? This structure we have here is glutamine. Glutamine. So you can draw that. All right, now number 10. Let's draw phenylalanine. Phenylalanine. Everybody in this class can draw phenylalanine. Now, look at the word. Phenyl what? Alanine. And you all know the structure of alanine, right? And recall that when you use benzene as a substituent, you call it what? Phenyl, right? When you use benzene as a substituent, you call it phenyl. Phenylalanine, meaning alanine plus what? Benzene ring. So you just draw your alanine. This is alanine, right? Is it not? Phenylalanine, meaning add benzene to alanine. But if you know we are adding something here, we have to remove one hydrogen, right? So you add your benzene ring here. This structure you have on the board is what? Phenylalanine. Do we get? This is phenylalanine. Please, I'll give you time to draw. Just listen up. This is phenylalanine. Number 11. If you know how to draw phenylalanine, then you know how to draw thyroxine. If you know how to draw phenylalanine, you know how to draw thyroxine. The only thing, if you are drawing thyroxine, draw the structure of phenylalanine back. Draw the structure of phenylalanine. This structure I have on the board is what? Phenylalanine, right? If I add OH here to phenylalanine, it becomes what? Thyroxine. It's as simple as that. Please, so for you to get used to it, draw it often and often. Alright, draw that before I clean. Number 12 now. Let's draw another simple amino acid, serine. If you've been following up our lessons, you see that serine is classified based on structure as OH containing amino acid, right? It contains OH. Just add OH to alanine, that will give you serine. If you have this, we all know the structure of alanine now, right? This is alanine, is it not? If I add OH to alanine, what do I have? Serine. This is serine. If you know the structure of serine, the good thing about it is, if you know the structure of serine, you know the structure of threonine. If you know the structure of serine, then let's draw threonine. Threonine is also OH containing amino acid, right? Now, draw this structure. Let me see who is paying attention. Look at this structure and tell me the name. What's the name of this structure? Serine. Serine, right? Yes. For some persons will say, why is the OH bent like this, not like this? It's still connected to the same carbon now. So this structure is still what? It's still serine, right? Now, if I add a methyl group here, this is threonine. This is the structure of threonine. So the OH is on carbon 1 here on as the side chain. So this is the structure of threonine. Draw that. We have how many more remaining? All right, number 14. Let's draw 16. Now 16, based on structure, classification based on structure, 16 is what? SH containing, right? SH containing. So if I add SH to alanine, what do I have? So if I have alanine here, say benzene, and 16 is part of it. Phenylalanine. Yes, they are aromatic. Alright, so in 16, just add SH, sulfhydryl group, to alanine, and this is your 16. If you know how to draw 16, you know how to draw methionine. Remember, methionine is also SH containing, right? Sulfur containing. Now, for methionine, please look at the structure here, because the structure of this is a little straightforward. Now, for methionine, you still write your alanine back. But this time, if I add SH, you know it will give me what? 16, right? But I will have to add another CH2. If I want to attach, then the next thing is what? SCH3 again. So please listen, take note of that, because if it was other ones, if we've added CH2, we'll just add SH again, right? But now the SH is guided between two CH. So we have CH2, CH3. So this is the structure of methionine. That's why I say you should listen, because it's a little straightforward. All right. So this is it. We have 5 more. We are making progress. Now, number 16. Let's draw histidine. Now, when we're classifying amino acids based on structure, we said histidine falls under heterocyclic, right? Heterocyclic, meaning it contains heteroatom. Now, the side chain, just like as usual, always draw your alanine first. So our alanine, then what we are to attach to alanine in histidine is the imidazole ring. Imidazole ring. That was why I had to draw the imidazole ring. So the imidazole is a 5-membered ring, and this is its structure. So if you attach imidazole ring to alanine, what you have is histidine. So this is the structure of histidine. The next thing is, let's draw proline. Now there was something I said when we're classifying proline. We said proline is an amino acid, right? Strictly speaking, listen up now. Strictly speaking, proline is not an amino acid. It is an amino acid. It is not an amino acid because it does not have this general structure we're talking about. So here, it is not even a derivative of... Okay, now look at this. If you want to draw proline, start the normal way we used to start. If I have something like this, this is what? Alanine, right? Now this is how the structure of proline. So you can see we have as attachment 3 substituent, 3 methylene groups. But now it is not going straight. It is now attached to this. So is this a primary amine or secondary amine? If you have something like this, is it primary amine or secondary amine? Primary amine, right? Is this a primary amine or secondary amine? Secondary, right? And secondary amine is what? Amine. So that is why it is called an amino acid, not an amino acid. So proline is an amino acid. It is the only amino acid that has something like this. Other ones, they are derivatives of, but this one is bent to form this. So this is proline. So draw this. We have 3 more to draw and call it a day on this. So number 18, let's draw the structure of tryptophan. Tryptophan is also a derivative of alanine. Now, in addition to alanine, you have to add this heterocyclic compound, a double heterocyclic compound. One is 6-membered, one is 5-membered. If you notice, this is a benzene ring, right? A benzene ring attached to this 5-membered ring. This is the structure of tryptophan. This is the structure of tryptophan. I think that's all about the heterocyclic, right? Draw this, we'll draw lysine. Lysine is easy. Now, number 19 and number 20, let's draw them. Number 19 is lysine. To draw lysine, you draw your alanine. Lysine has 4 of these. Then amino group. So you have 1, 2, 3, 4 methylene group before the amino group. This is the structure of lysine. But you know, this thing is the same thing as writing one of them, then putting in brackets 4, then NH2, right? So anyone you do, you are correct. All right. The last one, arginine. Arginine, if you know the structure of lysine, you know the structure of arginine. Arginine also have 4 of these, an amino group, but arginine has trust issues with nitrogen. Arginine has trust issues with nitrogen. So what it does is, it gives nitrogen bodyguard. It gives nitrogen bodyguard. All right, okay, you understand what that means. Now look at this. Now 1, 2, 3. It's supposed to be 4, right? It's supposed to be 4, but the last carbon is shielded with amino group. So 1, 2, 3, instead of the 4th one, the last carbon all round you shield it with amino group. So you have the carbon is here, right? You are shielding it with amino group. So, but one of them is an imine. This is the structure of arginine. Did you guess it right? Yeah. All right. So, if you notice, we have 1, 2, 3. 1, 2, 3. But this is the amino group. This and imine. This is secondary. Now this is secondary. This is the only. So this is still diamino. Is it not? This is an amino group here. All right. So this is the structure of arginine. Still 1, 2, 3, 4 carbon. 1, 2, 3, 4 carbon. But the last carbon is shielded with amino groups. All right. So this with this we've gotten the structures of the 20 amino acids.